Hi, in this video I've got these two differential equations, dy dx equals y minus 1 times y plus 3 and dy dx equals x plus 3, and I want to match these two slope fields to whichever one of these differential equations it is. So if we have a look at part A, so we've got dy dx equals y minus 1 times y plus 3. So if we look at the right hand side here where I've got these two bracketed terms, we can substitute stuff into y and see what would happen to the slope at those points. And the two obvious ones to try are the ones that make these two be 0. So when y equals 1, dy dx would be 0, which means that there is a slope of 0. And also when y equals negative 3, dy dx would be also 0. And so if you've got a slope of 0, that's where you've got a horizontal asymptote. So that means that therefore there is a horizontal asymptote at y equals 1. And at y equals negative 3, there's also a horizontal asymptote at y equals negative 3. So we've got two possible horizontal asymptotes, which means we're starting to look at slope field B because we've got these two lines of 0 slope. We've just got to make sure that the general curving of the rest of the slope field matches to make sure that this is going to be our definitive answer. So we also want to think about what happens on either side of these asymptotes. So if we think about, let's do on the bottom, below y equals negative 3. So y is less than negative 3. What's going to happen to our slope? So what is going to happen to dy dx? So if we think about putting a number just under negative 3 into this, then, so let's just think about doing negative 4. So negative 4 minus 1 will be negative 5, and negative 4 minus plus 3 will be negative 1. And so we've got negative 5 times negative 1, we've got a negative times a negative, which is positive. And it would be the same as I keep getting more and more negative, because I'm only subtracting 1 and only adding 3. I would always be a negative times a negative being positive, so our slope is always going to be positive. So as I get more and more negative, my slope gets more and more positive. And we can see that happening on our graph here. As I move down below y equals negative 3, I've got a positive slope, and then I've got an even steeper positive slope, and so we're getting more and more positive. We can also have a look when y is going to be between our two asymptotes. So when we've got negative 3 is less than y is less than 1. And so what's going to happen to dy dx in between these two values? So let's just put in 0, that's going to be a nice easy one. We've got negative 1 times 3, which is, if I try saying negative 1 take 1 is going to be negative, plus 3 though is going to be positive, so we've got a negative times a positive, so it's always going to be negative. We're going to have a negative slope there. And if we look at our slope between our two asymptotes, they are all negative slopes in there. So that means that they are negative in there, so that's good, we're matching up so far. And lastly, when y is bigger than 1, what's going to happen to our slope dy dx? So let's have a look here. When we're bigger than 1, I'm just going to subtract 1 off of it, so I'm going to stay positive, and I'm going to add 3 to it, so I'm going to stay positive, so we're also positive, which means that as I get higher and higher away from this, we get more and more positive, which we do. So that means that dy dx equals y minus 1 times y plus 3 matches slope field B. Because we've got an asymptote at 1 and an asymptote at negative 3, As I get more positive y's, I asymptote up towards more positive x. Between these two, I've got a negative slope asymptoting down in there. And then below this, we're asymptoting more positive, but our slope is more positive. As we go down, we asymptote it as well to positive infinity. So our solutions to this would actually be interestingly looking curves, kind of like what we've got going on here that I've just been drawing. So let's do the same for part B. Part B, we have dy dx equals x plus 3. So there's not much really that we can talk about with this one. We just have to think about what happens at different values within our slope. So let's think about what's going on with different values of x. So let's actually have a look. When x equals negative 3, what's going to be our gradient? So we're going to have negative 3 plus 3, so dy dx is going to be 0. So therefore, at x equals negative 3, we're going to have a horizontal slope. So let's now have a look at either side of x is negative 3. So let's look at if we're bigger than negative 3. So if we're bigger than negative 3, dy dx is just going to add 3 onto it. So we're going to stay more and more bigger. So that means that dy dx is going to be bigger than 0. And if we look at when x is less than negative 3, dy dx, we're adding 3, but because we're less than negative 3, we're never going to quite get above 0. So we're always going to be less than 0. So if we look at our graph, I want at x equals negative 3 to always have slopes of 0, which I do. X equals negative 3 has lots of slopes of 0. And as I get higher x values, I'm going to be increasing my slope, because as x was bigger than negative 3, my slope increased. It was bigger than 0. And when x is less than negative 3, I should have negative slopes, which I do. As I am moving negative on the x, I've got lots of negative slopes. So we do match up. So that means that dy dx equals x plus 3 matches slope field A. And that's it, we're done. So if you want to make sure that a slope field matches a differential equation, or that a differential equation matches a slope field, or to make sure that the slope field you've drawn is correct, you can look at different values on your right hand side and think about what effect that they're going to have. We had gradients of 0 at constant y's, which means that we have these horizontal lines of asymptote, and we had gradients of 0 at a constant x value, which means we had these, well in this case it's a minimum, it could have been a maximum, they're turning points. And then we can look at what happens as we're above or below each of those interesting points, and we can make sure that the slopes match up.